Hello, welcome to Simply Math. Today, I'll show you how to find all the asymptotes of a rational function. This includes vertical asymptote, horizontal asymptote, and the slant asymptote. For our video today, we will use this example throughout the video. So we're going to have x squared plus 3x minus 4 over x plus 2. Asymptote is a line that the function approaches but never touches. When you have a vertical asymptote, you have an x value, but y is undefined. When does this function become undefined? That is when you have a denominator of 0. So to find the vertical asymptote, we're just going to set the denominator to be equal to 0. So we're going to have x plus 2 equals 0. So when you move the negative 2 over, x is negative 2. So your vertical asymptote is at negative 2. That is when the function is undefined. So vertical asymptote, we just set denominator equals to 0 and then solve for x. Next, we're gonna have horizontal asymptote. So for horizontal asymptote, we have 3 cases that may happen. So I'll show you a trick to remember this. We're gonna say Bobo, but no, it's DC. You can think of Bobo and Botno as 2 robots, if that helps you remember better. What it says is that bigger on bottom, the asymptote is y equals to 0. If you have bigger on top, you have no asymptote. And then exponents are the same. You divide the coefficient. If you have bigger degree on bottom, you have the asymptote of y equals 0. If you have bigger degree on top, you have no asymptote, no horizontal asymptote. And then if the exponents are the same, you divide the coefficient. So the degrees that we're talking about are the greatest exponents of the whole polynomial. So for example, for the numerator, the exponent would be a 2, but for the bottom, the exponent would be a 1. So in this case, what we have is bigger exponent on top, which is our second scenario. So for this one specifically, we say we have no horizontal asymptote. However, let me show you an example of the other 2 scenarios. So bigger on bottom. Example, let's say if you have x plus 2 over x cubed plus 3x plus 7, then the exponent of the top would be a 1 and the exponent of the bottom would be a 3. So your horizontal asymptote would be y equals 0. For the last scenario is when your exponents are the same. So the example would be x squared plus 5x plus 6. And this is just a random example that we're looking at. With this example, your exponent on top is a 2 and on the bottom is a 2. So exponents are the same. Divide the coefficients. Our coefficients in this case are just 1 and 1. So we're just going to have 1 over 1, which is a 1. And would it be an x equals or y equals? Well, because we're having horizontal asymptotes, and remember a horizontal line would be a y equals line. And so your horizontal asymptote would be y equals to 1. So the last thing that I'm going to show you today would be the slant asymptote. And we're still using the example that we used earlier. So a slant asymptote only happens when the degree on top is exactly 1 more than the bottom. So example, x squared degree 2 is 1 more than x with a degree of 1. So to find the slant asymptote, you would need to do long division. I'll briefly show you how to do it in this example, but if you need a video just about long division of polynomials, I'll make a video about it. Okay, so this is how you set it up. Your denominator is going to be the divisor, and your numerator is the dividend. So to do long division, we're going to look at each term at a time. So we have x squared divided by x. You can do it on the side like this. X squared divided by x is just an x. So that x is part of your quotient. Then you multiply x times x is x squared. X times 2 is 2x, positive 2x. Then you subtract all of that. Okay, 2x minus 2x is 0. 3x minus 2x is 1x. And negative 4 subtract nothing. Negative 4 subtract 0 is just negative 4. Now we're going to continue with this x divided by that x. So x over x would just be 1. So we have plus 1. 1 times x is x. 1 times 2 is positive 2. Then we subtract it out. X minus x is a 0. Negative 4 minus 2 is negative 6. So this is your remainder, but we don't need that for the slant asymptote. Your slant asymptote is your quotient. Okay, so this is your quotient. And your slant asymptote is y equal x plus 1. Slant asymptote. So we would say that the slant asymptote only happens when the degree on top is exactly 1 more than the bottom. Then do long division. And then your slant asymptote is y equals the quotient. So back to our example problem. We found out that this is the slant asymptote. We found out that it has no horizontal asymptote, and that the vertical asymptote is x equals to negative 2. So if you're asked to sketch the graph of this function, you can use these 3 pieces of information to estimate what the graph looks like. So this is what the graph would look like. The blue lines are the actual graph. And as you can see here, we have a vertical asymptote at negative 2. So the graph approaches the line x equal negative 2 right here, but it doesn't touch it. And then we have a slant asymptote, which is the red line. And we have no horizontal asymptote. That's all for today, guys. If you have questions or any topics that you would like me to make a video of, just let me know in the comment section below. I'll see you again next time. Bye-bye.